Chapter 4, Section 4, More on Rational Expressions and Complex Fraction. In this chapter, what we're going to do is the same thing that we did in the last chapter, or the last section. We're going to continue to add and subtract fractions. The only difference between this section and the previous section is now we're going to have to factor the denominator first before we find a common denominator. So, the true steps to simplifying rational expressions is, number one, you're going to have to factor the denominator if possible. Now, like I said, in the previous section, we didn't have to factor the denominators, but in this section, we are going to have to factor them. Once you have got them factored, you're going to find a common denominator like we did in the previous section, and then write your equivalent fraction using that common denominator, and then combine the numerators and place over the common denominator, and then reduce if you can. So, the first thing we need to do is we need to look at our denominators and factor them. So, the denominator on the left, this one, will factor into x times x minus 4. I can factor an x out, and that's all that will factor. And so now I have to find the common denominator, and remember, in order to find the common denominator, you have to use everything once. So what I say do is write down everything that's already in common, which is this x, and then anything that's not in common, which is this x minus 4. So that's going to be your common denominator. And if you'll notice, your first fraction here, it already is the common denominator, so that numerator and denominator is not going to change. But if you look here and you ask yourself what's different from this fraction to this new fraction, and it is that we multiplied by an x minus 4. So basically this fraction needs an x minus 4. So we'll multiply the top and the bottom by x minus 4. So on the top we'll use the distributive property because we need to combine things in a minute. And on bottom you just leave it as multiplication. Alright, so let's make one fraction. If we make one fraction out of this, we're going to have 2x, and then 8 plus a negative 8 is going to go to 0. And then you're going to have x over x minus 4. So, step number 1, factor the denominator if possible. We did that. Step number 2, find the common denominator. We did that as well. Step number 3, write your equivalent fractions, and then combine your numerators, and that's where we are now. Now the last step is to look to see if we can reduce, and at this point, if you can factor, factor. If you can't factor, then leave it be and look and see if anything will reduce. This x will cancel out with this x because it's monomial. They're both monomials and we can cancel them. So now what we're going to have is 2 over x minus 4. And remember, you may want to reduce the 2 and the 4, but you can't because this is a group, so this is going to be your answer. So let's try again. Here, we're going to factor this into a plus 1 and a minus 1. So that is going to be the difference of two squares. Let me write that a little bit better. Okay, and so now what we're going to do is we're going to find that common denominator. And remember, to find the common denominator, you're going to write down what's already in common, which is going to be this a plus 1 group. So you know that your common denominator is going to include what's already in common, which is the a minus 1. And then what you have to do is you have to go back and write down anything that's not in common. So we don't have the a plus 1 in common, but we need it. So, again, that first fraction is not going to change because it already carries the common denominator. But the second fraction, it is missing an a plus 1. So we're going to multiply the top and bottom by that a plus 1. So on the top, again, it's the distributive property because we're going to have to combine the numerators in just a minute. But on bottom, we've already done the multiplication, but we're going to leave it as is so that we can reduce later on. So the numerator, we're going to combine that, so we'll have 6a plus 5a, which is going to be 11a, and then 4 and 5, which is going to be 9, over a minus 1 times a plus 1. And the numerator will not factor, which means this will not reduce, so that is going to be your answer. Okay, let's try this one. The a squared minus 4 is going to factor into a plus 2 and a minus 2. So again, our common denominator, we're going to write down everything that we see that's in common, which is going to be the a plus 2 group. And then we're going to write down anything that's not in common, which is going to be that a minus 2. Alright, so now we need to write an equivalent fraction. If you'll notice, this denominator is the common denominator, so the numerator is going to stay the same. But this one, we have an a plus 2 and we need an a minus 2, so we're going to multiply the top and the bottom by that a minus 2. And the denominator, technically we've already done that, but the numerator we're going to distribute, so we have 3a minus 6. Combine like terms, a minus 3a is going to be a negative 2a, minus a negative 6 is going to be a plus 6, and then over that common denominator. At this point, we need to factor out that negative 2 in the top, which is going to give us negative 2 times a minus 3, and then on bottom is your common denominator. And then we need to look to see if anything will reduce, and it won't, because none of these three groups are the same, and we don't have anything to cancel the negative 2 with, so that is going to be your answer. For this problem, both of our denominators will factor. We have trinomials. Excuse me. We have trinomials where the leading coefficient is 1. So both of these will factor into our two binomials. So the first one's going to factor into n plus 5 and n plus 1. And then this one is going to factor into an n minus 8 and an n plus 1. So those are our new denominators completely factored. Our common denominator is going to be what's in common already, which is that n plus 1. Remember, if it's in common, then it's going to be part of the common denominator. And then we need to write anything that's not in common, which is going to be that n plus 5 and the n minus 8. Alright, so we have to write an equivalent fraction. So in other words, we have to change this numerator if the denominator changed. Well, from here to here, we multiplied by an n minus 8. So we have to multiply the top by an n minus 8 as well. So we'll have 3n squared minus 24n. And then here, to get from the old denominator to the new denominator, I need that n plus 5. Alright, so we'll have 4n plus 20. So on the top, we'll combine where we can. So we have 3n squared. Negative 24n plus 4n is going to be a negative 20n. And then we have plus 20. Over that common denominator. And at this point, we would try to factor this trinomial. There's nothing that we can, because remember you would have to use bottoms up, so we would multiply the 3 times the 20 and get 60, and there's nothing that we can multiply together to get 60 but add together to get negative 20, so it will not factor. And this is your answer. Okay, this problem, our first denominator is going to factor actually 3 times. It's going to go into x squared plus 1 times x squared minus 1 initially, but then the x squared minus 1 will go again. So that's what the denominator is going to be here. And let's just rewrite that. We'll have 2x squared over x squared plus 1 times x plus 1 times x minus 1. Now, the fraction in the middle, that's the difference of 2 squares on the denominator, so that's going to go into x plus 1 and x minus 1. And then that last fraction will not factor for the denominator, so we'll leave it as is. So let's see if we can figure out what the common denominator is going to be. So the common denominator, you're going to write anything that you see in common. Well, I see an x minus 1 that's in common with all three groups. So x minus 1 is going to be part of the common denominator. And then anything that's not in common, so the x plus 1 is not in common with all three groups. And then of course the x squared plus 1 is not in common with all three groups. So now we have to work on our numerators. There's nothing that changed in this first denominator from the old to the new, so the numerator's not going to change either. Here we multiplied this denominator by an x squared plus 1 in order to get the common denominator. So we're going to multiply here by x squared plus 1. And use the distributive property, we'll get x to the third plus x. Now here, we multiplied by an x plus 1 and an x squared plus 1. And of course, anything times 1 is itself, so if we full this out, we'll get x to the third plus x squared plus 1. Alright, so now that we have a common denominator, we're going to make one fraction over that common denominator. And then let's start with combining the numerator, but we're going to have to start with the highest exponents. We have a negative x to the third and a negative x to the third, which is going to be negative 2x to the third. Oh, you know what? I thought that looked a little weird. This is supposed to be a plus sign, so that helps a little bit. So if we have x to the third, a positive x to the third minus 1x to the third, that's going to be 0. And then if we have a 2x squared minus 1x squared, is going to be an x squared. And then if we have x minus x, those are going to cancel out. And then we have minus a 1. Okay, so we have our new fraction, and we're going to factor now so that we can reduce. That x squared plus 1 is going to go to x plus 1 and x minus 1. That's the difference of two squares over that common denominator. And now we're going to see where we can reduce. The x minus 1s will go away, the x plus 1s will go away. And remember, if everything cancels out, it goes to 1. So we have 1 over x squared plus 1 as our answer. Alright, so what I would like you to do is I would like you to pause the recording and try these problems just to see how you'll do. If you have any problems, bring them in. And when you finish working on these, then you can continue the recording and we'll talk about something else. Alright, the next thing that we're going to talk about is complex fractions. Complex fractions basically is one fraction over another fraction. So you have to have one fraction over another fraction, and this fraction bar in between fractions are nothing more than division. So basically what we see here is a fraction divided by another fraction. So to simplify a complex fraction, what you're going to do is you're going to simplify the numerator and the denominator. And what that means is you're going, if you have two fractions, and I'll show you, like this is not simplified because we have two fractions over two fractions and we need one fraction over one fraction. So we'd have to find a common denominator and simplify that. So when it says simplify the numerator and the denominator, that means you need one fraction over one fraction. So if you already have that, like we do in this example, then you can skip step number 1. Step number 2 says to rewrite the complex fraction as a division problem. Well, it's like I told you, this bar basically is a division symbol. So what you're going to have is you're going to rewrite it like we did in 4.2. So you're going to have 4 over x divided by 2 over xy. Well, you know that you can't divide fractions, so we're going to change flip, keep the first one as is, change division to multiplication, and flip that second fraction. We've already worked on this. Reduce where we can, so 2 will go into itself 1 time, 2 will go into 4 2 times, and the x's will cancel out, and then multiply straight across. So if we multiply straight across, we get 2y on top and just 1 on the bottom. You can write it or not. So simplify the numerator, one fraction over one fraction. If it's already set up that way for you, you're going to rewrite the complex fraction as a division problem. And then go back to the rules for dividing rational expressions in 4.2, which basically says take your division and do keep, change, flip, multiply by the reciprocal, reduce where you can, and then multiply straight across. Now, there is a little trick to these complex fractions, and I call this skin over guts, because if you take your body, your skin is on the outside and then your guts is on the inside. And so to do skin over guts, what you're going to do, and I'll do this in black so that you'll see what we're doing. So skin, that's going to be the outside two numbers. So what you're going to do is you're going to multiply those two numbers together. So if you have 4 times xy, you're going to get 4xy. And then over guts, the guts are going to be the inside two expressions. So x times 2 is going to be 2x. And now from here, what you're going to do is you're going to reduce. So 2 will go into itself 1 time, 2 will go into 4 2 times. The x's will cancel out, and you can see that you're going to get 2y again. So you can either do what we did in 4.2, which is write it as a division problem, keep, change, flip, reduce, and multiply straight across, or you can try the skin over guts. So I like doing skin over guts because it's easiest to me, so that's what I'm going to continue showing you. But like I said, I've already showed you how to do a division problem in 4.2, so if you want to go back and look at those notes, you can do the division problem if you don't like the skin over guts. So if you have one fraction over one fraction, and I hope you understand the difference, because here we have two fractions. You have a 4ab minus 3b squared, two fractions over two fractions. You can't do anything with that just yet. But if you have one fraction over one fraction, you can go ahead and do the skin over guts. So the skin is going to be 5 times 3xy, which is going to be 15xy. And of course, to know how to do this, you have to know how to multiply, and we covered that in 4.2. Actually, we covered it in chapter 3. And then 6y times 10 is going to be 60y. From here, you'll need to reduce. So 15 will go into itself 1 time, 15 will go into 64 times, and the y's will cancel each other out. So on the top, I have an x, and on bottom, I have a 4. Now, what happens if you don't have one fraction over another fraction? What do you need to do? Well, you need to simplify, which is what we just came through in 4.3 and technically in 4.4. So I need to subtract these two fractions. In other words, I need to find a common denominator. Remember, to add or subtract fractions, you've got to have a common denominator. I need to find a common denominator, which for the top is going to be a and a b squared. There's already a b in common. But I have another b here and an a here, so I need to include everything. So that's where I get ab squared from. So for this fraction, that new numerator, I need another b, so that's going to be 4b. And here I need an a, so that's going to be 3a. Alright, for the bottom, the common denominator is going to be ab. So this fraction here needs b, so 1 times b is b. And then the second fraction needs a, so 3 times a is 3a. Now what I'm going to do is I'm going to make one fraction, which is what I need. So I'm going to have everything over my common denominator, which means I'm going to put that numerator together, but those are not like terms, so I'm just going to write down what I see. And on the bottom, same thing. Put everything over that common denominator. These are not like terms in the numerator, so I will just write what I see. So now I have one fraction over another fraction. So I'm ready to do skin over guts. And like I said, if you don't like skin over guts, then you can change this to a division problem, and I'll show you what that looks like. If you change it to a division problem, it's going to be 4b minus 3a over ab squared divided by b minus 3a over ab. And then of course you know that you would keep, change, flip. So keep the first one as is, change division, multiplication, and flip that second fraction. And now that you have a multiplication problem, you can reduce where you can, which this problem, the a's will cancel and the b will cancel one of those, and nothing else will reduce, because remember, this is a group, and those groups are not identical. So on top you would have 4b minus 3a, changing colors way too much, over b times b minus 3a. Or you can do the skin over guts, which is what I prefer to do. So I'm going to have AB times 4b minus 3a, and I'm not going to multiply that out because I want to reduce. And then I'm going to have AB squared times b minus 3a. So this a will cancel this a, this b will cancel this one, and the two groups we've already discussed are not the same, so those won't reduce. So on top I have 4b minus 3a over b times b minus 3a, which is exactly what we found here. So let's try that one more time. I want to make these two fractions into one fraction. So in other words, I'm going to add on top and I'm going to subtract on bottom. So in order to do that, I've got to have a common denominator. So the common denominator on top is going to be xy. So that left side numerator needs a y, so it's going to be 3y. And the right side fraction I had to multiply by x, so that's going to be a 2x. On the bottom, I have xy squared. Remember, you have to use everything once. So you have xy squared. So that left side fraction I had to multiply by 5y squared. And that right side fraction I had to multiply by an x. So you get 6x. Alright, let's make it into one fraction. So we have 3y plus 2x over xy. And I have 5y squared minus 6x over xy squared. And then if we do skin over guts, we're going to have 3y plus 2x times xy squared. It doesn't matter how you write it. And then guts is going to be xy times 5y squared minus 6x. And then what would reduce will be the x's and one of these y's. And then of course those groups are nothing alike, so we can't reduce those. So we're going to have y times 3y plus 2x over 5y squared minus 6x. And we're just going to leave it like that. So what I'd like you to do is I'd like you to try these three problems on page 210. If you have any issues, bring them into class and we'll